Hi everybody. So you probably know the LA-2A compressor, the LA-3A maybe, but I really feel that the LA-4, their younger brother, just doesn't get enough love. And so we're going to go a little ways to correct that today by tearing it down, of course. So I'm really excited to get into this, in part because I have a personal, or our company has a personal connection to the LA-4, which I'll get into in a little bit, but also it's just a very funky piece of gear, and I'm excited to explore that with you. So let's take a look. Looking at the front panel, you can see that we are in the vein of the LA-2A, LA-3A, but with some differences. So this threshold control would have been called input on those. We still have this called output. We also have these kind of dual things where one of them is a potentiometer and the other is a switch, which is really cool. And so the switch controls like the ratio and the meter, while these control the threshold and the output, which is pretty cool. There is a stereo link setting, and then power, and then the meter. So pretty straightforward. Oops, the fuse fell out. Anyhow, let's take a look at the back. So one thing you will notice is that there are no XLR jacks. You actually have to bring audio in on these screw terminals. So that makes racking this up, a bit of a project. And then this is an input range for basically how hot, whether you're sending like pro or consumer level. And then this is for stereo linking between two units. This is the fuse and the voltage select for the wall, and the fuse just fell out. But love these old details, like this metal sticker here with the serial number, and this is certainly a vintage detail, not something you see much anymore. All right, let's look at the circuit though, and be down here. So over here's all our power stuff, big power transformer, big regulators, big capacitors for power. So standard kind of linear power supply and vintage equipment. All that's over here. Now, if we're looking at the audio path, one thing we can note right away is that there's only one transformer. This is the transformer. In most kind of pre-1980, pre-late 70s gear, you'll find two transformers. And that's because this has a solid-state IC-based input receiver instead of your typical transformer. And that really brings us to what is unique, a big part of what's unique about the LA-4 as opposed to its older siblings, the LA-2A and the LA-3A, which is that the LA-4 uses ICs. Now, the ICs are these silver and black ones, and then also this yellow one. Oh, I just love that, like mustard. So awesome. Now, you just don't. All ICs are black now, but how cool would it be if they still made them in that color? Anyhow, so this was first released in 1977. IC op amps first became a thing in like 1968. So ICs had some time and they had come a ways, but they had not come that far. And that is really why the LA-4 is not as well known as the LA-2A and the LA-3A, because ICs just weren't ready for prime time, and they put them in there. And the ICs in here, they're kind of slow, meaning that the slew rate is kind of slow, so you get a lot of slew rate distortion. And I think people would normally describe the sound of these particular ICs as slow, dirty, kind of mushy, kind of dark, which can be cool. I'm looking at an LA-4 now. People certainly buy them, but you need to know what you're getting into, and it's not as, you're not going to put it on everything. It's kind of an effect. These ICs are RC41 LA-36. So these are long obsolete. This was basically a quad version of the 741 op amp, which was, if not the first, the kind of big watermark first integrated circuit op amp. So, and it just sounds like crap. I mean, again, you can do cool things with it, but it is not a star performer. But enough trash talk about the LA-4. I love this thing. Now let's talk about what's great about it. And what's really great about it is the sidechain, the compression. So like the LA-2A and like the LA-3A, it's an optical compressor. But unlike those two, instead of using the T4B Opto cell, it uses an LED, which are under here. You can't see them, but there's two LEDs here. And then these are LDRs, light-dependent resistors. So they're just resistors that change their resistance based on the luminosity of the LED, and then you can see they're in this like little black tube here. And I said that I had a personal connection to this product. Our OLA-5, the DIY recording equipment OLA-5, is a replica of this exact sidechain. I love this sidechain. I love its opto, so it's slow and musical, but it can be very grabby and very weird and aggressive in really unique ways. So I've spent a lot of time with this circuit. We changed the audio path so it didn't have the same kind of muddiness as the LA-4, but I love the sidechain, and that's what makes this thing really cool. But let's just talk about the rest of the circuit here before I go into a block diagram. So you see the ICs for the signal path. These are the optos that actually do. One of them does the gain reduction and one of them does the meter. You have to have, in something like this, you have to have two. It's basically two compressors, but one is just to drive the meter. There's really no other way to do it. And then you have some trim pots for kind of setting stereo matching or trimming the threshold and that kind of thing. Kind of WEMA film capacitors, so high quality stuff there. And then, of course, this huge meter really takes up a ton of real estate. And that's about it. Not too much remarkable parts-wise. So I'm gonna go over and show you a block diagram. As I mentioned, the input to the LA-4 is a solid-state op amp. So this is our balanced input here. Comes out unbalanced. This is what would have been done with a transformer and in other things. And then we go straight away into the gain reduction. And we'll kind of zoom in more on that in a minute. But after that, we have a fixed gain stage for our makeup gain. And then I'll just show you the makeup gain kind of pot right there, potentiometer. And then there's another active stage, which is kind of a buffer, which then goes to this transformer for our balanced output, and that would go to ground. So that's the signal path right there, and as I said before, this would have been all integrated circuits here. Input, gain, buffer, all integrated circuits, so plenty of chances for the audio to get kind of mushy. But let's look at the gain reduction, which I'm going to make bigger here. The gain reduction is just a voltage divider. So if you have seen the 1176 teardown video, this is all going to look very familiar. So the gain, we come in right from the balanced input, we have our gain reduction. A voltage divider is just two resistors, R1 and R2, and the ratio between them, I won't get into the formula, but basically, depending on their values, it changes the amount of voltage here, which is V out. And so by changing, we leave one of them fixed, basically, and then we vary this one. And the lower the resistance gets here, the less voltage there is here. So you could put a knob here for a pot here to make a volume control. You could put a capacitor here to make a filter. We won't get into that. But what they've done is they've made this a light-dependent resistor. And so the light coming from those LEDs makes this lower resistance, which means lower output. So we're missing something big from our block diagram here. Yes, you guessed it, it's the sidechain. So we take the sidechain off of here. So again, this is a feedback style because we're taking the sidechain after the compression. So the compression is actually seeing its own compression. It can do a lot of kind of self-correcting and compensating that way. But this is what we call the sidechain, where all of the audio is converted to DC. We set the ratio, we set the threshold, all that's in here. Ratio, threshold, etc., etc. But then we have a DC control output. That's the result from our sidechain. And that comes around here, and it drives a diode. A light-emitting diode. And that light-emitting diode controls the resistance of this LDR, this light-dependent resistor. And that's really all there is to it. So this is very, very similar to the 1176, except that instead of having a FET controlled by DC here, we have an LDR, which is controlled by an LED, which is in turn controlled by the DC. And so isn't that just wild? I mean, that there is like actually light happening here. So a couple thoughts about this topology. Opto compressors in general are very, very slow. Slow attack time, very slow release time. And that is a bit counterintuitive because you say, well, it's light, it's optical. Surely nothing is faster than light. Well, it's not the LED that's slow, it's the LDR. The LDR is a chemical response to light that just takes a while. It just takes time for it to respond to the light. So the light is going to flicker, well, not necessarily flicker, but it's going to go up and down in luminosity as the control voltage changes here instantaneously. And then the LDR is going to kind of take its sweet time to respond, and that's what makes this so cool. And it also isn't linear. If you saturate this LDR with a bright light, like a big bass note, for several hundred milliseconds, it's going to take longer to release back to its resting state than if you just did a quick burst like a kick drum or something. So you get all these kind of unpredictable, nonlinear effects from this, and that is what we love about analog stuff in general, and opto compressors in particular here. So that is a bit of a walkthrough of this beauty. I don't know if it's a beauty. I would call it more of it's more of a cutie. I mean, look how adorable this thing is. But I hope this gives you a better sense of kind of what's special about the LA-4, some of the compromises that make it, not so exorbitantly expensive on the vintage market. And if this sounds interesting to you, I certainly have to plug our OLA-5 compressor because it is based on this exact same sidechain. So, hope you enjoyed this one. Thanks very much.